Moving on to question 7 now, we have a question here that's looking at the roots of a complex cubic polynomial here. And part of the question is looking at using the roots of a polynomial to answer this. Okay, so let's jump straight into this. So part A, it asks us to solve completely the equation f of z equals 0. So f of z is this cubic polynomial here, so z cubed minus 8z squared plus pz minus 24. And we know p is just a real constant. So it's got distinct roots, it's got alpha, beta, and alpha plus 12 over alpha minus beta. Okay, so we need to get these roots. So how do we get these roots? Well, the first thing we can know is that we're going to need to work out a value for alpha beta. So alpha beta, how can we get this value? Well, the first thing I can know is that, imagine this is alpha beta, and I'm going to call this one gamma. So that's the root gamma. So I know alpha plus beta plus gamma, well, that's going to be equal to minus b over a. So minus b over a. Well, minus b over a, well, my b here is minus 8, so minus 8 is 8. So what it's going to be is 8 over 1. So alpha plus beta plus gamma, but my gamma is this here. So let's substitute that in. So do that over here now. Plus alpha plus 12 over alpha minus beta, and we know it's equal to minus b over a, where minus b over a is equal to 8. Okay, so that's equal to 8 like so. Well, we can simplify here, right? Alpha plus alpha, that's equal to 2 alpha. I've got beta minus beta, so they cancel, and I've got 12 over alpha plus 12 over alpha, and this is equal to 8. So now, what can we do here? Well, I can multiply through by alpha. So if I do that, that will give me 2 alpha squared. If I multiply this by alpha, I'm just going to get plus 12. And then if I multiply the other side by alpha, I'm going to get 8 alpha. Okay, so getting this as a quadratic now, which is equal to 0, this is going to be 2 alpha squared plus, minus 8 alpha plus 12, and that's equal to 0. So now we can simplify here, dividing each term by 2. So that's going to be alpha squared minus 4 alpha plus 6 is equal to 0. And here now, we could have a look if this factorises, but a quick inspection, you'll find out that this doesn't actually factorise. So we're going to have to use quadratic formula. So quadratic formula, well, I'm just going to write it as, in fact, I'll write it as alpha. So alpha is equal to, so it's going to be minus b, but minus b here would be minus 4, so that's going to be 4, plus or minus the square root of b squared, so 16, minus, do it all in a bracket, 4 times 1 times c, where your c is 6. So 4 times 1 times 6, and we can close the bracket. And this is all over 2a, where a is equal to 1, it's the coefficient of it, alpha squared here. So that's going to be 2 times 1, which is 2. So let's just keep simplifying here now. So it's going to be 4 plus or minus 16 minus 24. So 16 minus 24, that gives me the square root of minus 8. And this is all divided by 2. Okay, keep simplifying. So it's going to be 4 plus or minus, this is alpha still, 4 plus or minus. So simplifying this square root of minus 8, so the square root of minus 8. So if you're unsure how to do this, it should hopefully be pretty easy, but you can split this up into 2 square roots, square root of minus 1 and 8. Well, the square root of minus 1 is I. The square root of 8, well, that would be root 4 root 2, so root 4 root 2, which is equal to 2 root 2. Okay, so this would be 2i root 2, so 2i root 2. And now this is divided by 2, and then we can divide each term by 2. So this is going to be equal to 2 plus or minus, sorry, where have I got 2? So 2 plus or minus I root 2. So that really wasn't that complicated. Not sure why I tripped up there. So 2 plus or minus I root 2. Okay, so what I can say now is that them are 2 of my roots, so therefore if we call it alpha, that's equal to 2 plus I root 2. Then if I say beta is 2 minus I root 2. Okay, so that's alpha beta, but we need this gamma here. Okay, we need that third root. But we can use this, right? This only uses alpha and beta. So let's use this. So we know alpha plus 12 over alpha minus beta should be equal to 0, right? That's my root. So if I set that up now, that's 2 plus I root 2. So I'll just split this off here. Underneath, so 2 plus I root 2 plus 12 over this. Minus beta, which is minus, never do it in a bracket, 2 minus I root 2. Okay, like so. So now, the first thing I'm going to have to do here is multiply this middle term here by the conjugate, 2 minus I root 2. So, if I just write it out again, 2 plus I root 2 plus 12 lots of the conjugate do the same with the denominator. Like so. And then we subtract this beta term here. So minus 2 minus I root 2. So now, we're going to have to simplify this. So I've kind of run out of room here. So what I'm going to do is I'm just going to change my pen to yellow and then do it at the top. So I'm taking this all the way to the top now, all the way up here. So if we do this at the top, well, let's just simplify the middle term. So this would be 24 minus 12 I root 2. So 2 plus I root 2 plus 24 minus 12 I root 2. This is all over now. So this is the difference of two squares, remember? So the easy way to work this out is square the first two terms of each bracket and then multiply the first two terms together and then multiply the last two terms together. So 2 times 2, so that's going to be 4. And then if you multiply I root 2 with minus I root 2, that'll give you minus I squared times 2, which will just give you a positive 2. Okay, so it becomes 4 plus 2. And then this final bit will be minus this 2 minus I root 2. So minus 2 minus I root 2. So I'm kind of running out of room here. It's a bit of a tight fit. So now we can keep simplifying. This is going to be 2 plus I root 2. So this is 24 over 6, so that'll be 4 plus 4 minus 12 I root 2 over 6, that'll be minus 2I root 2. And I've got minus 2 plus I root 2. Okay, just multiply that out by the negative. Plus I root 2. Well, if you look at each term here, what will actually happen? Well, you've got 2 lots of I root 2 and you've got your minus 2 I root 2. So they cancel with that. And I've got 2 plus 4 minus 2. So that just gives me 4. So my third root here, my final root gamma is equal to 4. Okay, so 3 roots are my alpha and beta, which were basically the plus or minus, so it's 2 plus or minus I root 2. And we've also got 4. Okay, so them are the 3 roots there for part A. So if we just clear this now, just to carry on with part B. Well, for part B, we worked out that one of the roots is 4, so root of 4. Well, if we know that a root is equal to 4, we've got a root of 4, well, using the factor theorem now, so what that is that the fact that f of 4 will be equal to 0. Substitute 4 into this cubic polynomial here, set it equal to 0, we can obtain a value for p, nice and easy. So, doing that now, that's going to be 4 cubed minus 8 lots of 4 squared plus p lots of z, where z is 4, so 4p minus 24, this is equal to 0. So now, just putting all this in on your calculator, it's going to be 64 minus 128 plus 4p minus 24, and this is equal to 0. Simplify this side, your left hand side of your equation, you get 4p minus 88 is equal to 0, so therefore 4p is equal to 88. Divide each side by 4, to get 88 over 4, or get p equals 22. And there we have it. So that's the value for p. You should get 22. And that gives us question 7 fully complete.